I started my career after I got the diploma, the degree actually, not diploma. After I got the degree in astrophysics. First I started working on what I call the new power system. In this respect we are talking about solar power and power from wind. And I worked there for just over a year. So I get an expertise on photovoltaic systems. And then after that I won a permanent position with the Research Council in Italy, where they were working on space activities, mainly what they call ionospheric physics, meaning the space around the Earth. And in this kind of research, I was working on a new satellite, a new generation of satellite, the so-called tethered satellite, that was supposed to be not a free flyer, but rather a satellite connected to the space shuttle with a long wire, 20 kilometers. And the idea was that since you have a conductor in space and you are moving around the Earth where there is a magnetic field, you can generate power just by a simple law, of power generation. And at this point, the idea is that you have the speed of the shuttle going around, you have the Earth magnetic field, and in order to provide a significant power, you have to make the wire very long. That's why we choose 20 kilometers. The experiment worked very well in space because after the development phase, this satellite had the chance to fly twice in space, and that was, by the way, the opportunity I got to become an astronaut. So my research work lasted for roughly 10 years, and then while I was working on this, there was the agreement with NASA to fly this experiment on the space shuttle. And that was the beginning of my new career as an astronaut. Yeah, it was a dream of a child, of course. When I was a teenager, I was like millions of other teenagers like me, watching the moon landing, watching the Armstrong and Aldrin walking on the moon. And for me that was really inspiring. I thought I want to be an astronaut. I was already reading a lot of science fiction, and I thought that to some extent the science fiction was getting real. But then when I grew up, I realized that Europeans, and particularly Italians, couldn't fly in space at that moment. So I chose what was the activity closer to space that I could find. And I graduated in physics, and I became an astrophysics. And so if I couldn't go into space, at least I could study space from ground. That was the idea. But then, as I said, many years later, it happens that what I was dreaming it became a reality, and I just sent my application because it was a public call. So I applied to this, and I was chosen at the end of a long process of selection. And two of us, myself and another guy, were sent to Houston for the first training. And at that time, what was a dream of a child was getting a reality, and I was thinking about that my life was going to change, and that's what exactly happened. Well, first of all, I was not really aware what it takes to become an astronaut. So I did it on just thinking about it was nice to do it. And then when you start, you realize how long it is the path to get there, and also how tough it is to really do all the steps that are necessary. In other words, you start at the beginning with, well, first of all, you have to be selected. That's the first big difficulty. I mean, you know that I felt that like I was ready from the technical point of view because I was working on space research. I knew that we were working on an experiment that I already knew very well, but I had no idea what would have been the medical requirements. And so I went through the medical selection that lasted for more than a week on the Italian side. I did the same thing then on the NASA side, because even though they gave to the Italians all the specs in order to proceed on the selection, they didn't quite, they were not confident about the selection, so they repeat, not all, but most of the tests that were done by the military, it was the military selection. I mean, it was made by Italian Air Force. And so I passed that in my opinion was the most difficult task, and then I went through the other tests, the technical test, the psychological test, the English test, and at the end we were selected, as I mentioned, we were two selected and sent to Houston. At that point you start your new career, you start your training, and the first couple of years is just going to a university classroom. I mean, in the morning you have lectures, you have all technical aspects of the space shuttle and of the payloads, all the safety issues and things like that. And in the afternoon you have a practical section doing actually real hands-on training. I mean, you know how the computer works, how the engine works, and things like that. It takes a couple of years to get knowledgeable about the space shuttle. It's a very complicated spacecraft. And at the end you have a final exam, like in the university. And if you pass it, generally you do. I mean, I never heard of something failing that test, because you are motivated. I mean, you know what is at stake at that point. So you pass the final exam, and at that point you are certified. You are a professional astronaut, you are ready for flight. It doesn't mean that you are going to fly next. You might wait a year, you may wait, somebody waited more than 10 years before the first assignment. And the first assignment means that you are called, one day you are called by the astronaut chief and said, you are in this crew. They give you the name of the other crew members, and you know at that time that you are 1 year away from your flight, because that's what it takes to get ready for the flight. So at that point you start what is called mission training, the training that is focused on the particular mission, what you are going to do in space. It may be different. I mean, in my case, the first mission was very different from the second. So every time you have to start all over again. And it takes roughly a year, and at that point it's time for you to get into the space vehicle, the real vehicle. After so many training sessions in the simulator, you get to for the first time to the real spacecraft, and that's it. That's the start of the flight. Yeah, of course you have to pass all the selection, and you have to keep your physical fitness and also your professional skills all ready for so many years that you are waiting. So you still have to be proficient in what you are doing, and that's the real challenge, because I mean you have to be focused for many years to one thing that is going to happen in the future, but you don't know when. So, but nevertheless, you have to keep training, keep doing exercise, keep to all the skills ready when they call you. So it is tough. But on the other hand, there is a big motivation. I mean, your dream is close. You don't know when, but you know that it's going to happen. I think 99% of the people that has been trained has flown in space. There are a few exceptions, but basically all the people that has been trained eventually had the opportunity to fly in space. So it's a tough job, but you are ready for, and you are motivated to overcome every difficulty. Well, there are differences. There are part of the flights that are very dynamic, very, I mean, they require a lot of attention. They last for a short time, like the launch. The launch is overall is 8 minutes, so it's really short time. But in that small fraction of time, everything can happen because it's very dynamic. You are sitting on a rocket that is basically going up straight at a tremendous speed. Everything happens so fast that you have to keep pace with that. And if something goes wrong, you have to react in a matter of seconds. And this is a life and death situation. You cannot miss that. And so you are trained for that very, very intensively. As the astronauts are used to say, 80% of our training is down in the basket when we reach orbit, because it's all focused on that 8 minutes. You do launch simulation over and over again in a section that lasts for 4 or 5 hours. You can imagine 8 minutes in 5 hours, how many times you repeat the same thing. Of course, every time is different. I mean, the training is not for a normal flight. It would be too easy. The simulator is used intensively to simulate off-nominal situations. That's why they require so much time. Basically, you have to simulate that something goes wrong on the computer, or the engine is quitting, or something else is happening on the electrical buses, on the hydraulic systems. I mean, there are so many systems that can fail on the shuttle that you have to try all the possible outcomes. And so every time you repeat a new simulation, something different happens. And you have to cope with that. I mean, you have to respond to that. And the response is what basically drives you during the simulation. I mean, the simulation, to explain what it is really a video game. On one side, there are the crew on board, I mean, on the simulator, and the ground controller on the main control room. On the other side are the people who actually designed the simulation. They made the simulation. And the two groups don't talk to each other. So you don't know what they are doing. And based on your response, they continue the simulation. So if you make the wrong response, the simulation goes in the wrong way. And that's the way you learn, by error. Of course, the first time you may error, but by error and trying, you learn the right way. And the simulation is so good, is so well done, that sometimes from the simulation they learn how to change the procedure during the flight. So it's really a good game, and they are very good at that. I mean, they are very professional, and everything happens as it is the real mission. Of course, there is no adrenaline there. I mean, you know that you are safe in a safe environment. But by the time you move to the real vehicle, to the real spacecraft, it seems more or less the same thing. I mean, it's not much different, because the simulation is so real that the real thing is almost identical. Yeah, it was different the second time around. But in a way, it was more, I mean, you pay more attention to the details, because the first time was so overwhelming. I mean, everything was happening. I mean, you know that, but you know because you have done it during the simulation. But as I said, the first time is so huge. I mean, one thing you cannot simulate is the physical sensation, because of course in the simulator we have some dynamic behavior. There is a movable simulator that can be put in vertical and somehow simulate the acceleration, but of course it's not like the real thing. And the other thing you cannot simulate is the lack of weight, I mean the weightlessness. There's something you cannot simulate. So, you can just do it on an airplane for 20 seconds, but that's not enough. So there are things that you cannot simulate, so you live for the first time on orbit. But more than that is that you have a lot of sensation the first time, so it's beautiful for that. The second time around, you know already what is going to happen. You know how your body will react to weightlessness. For example, the first time I was really worried if I would have space sickness. This is what it happens in the first few hours, or maybe days in some cases, when you are in space. You know, your body is changing, and you feel dizzy, you feel headaches and things like that. So I mean, I wouldn't say my problem, but my attention was, I hope I don't get sick on orbit. The second time I knew that I was not going to be sick, so I was relaxed, and so I noticed more details about when you get into orbit, the final phase, when you actually have to do all the reshuffling of things when you are on orbit, because you start on a rocket, and so you are sitting on your back, you are under high G's for most of the time, and all of a sudden you are in space, in weightlessness, so you don't need the seats anymore, you don't need some of the harness like the spacesuit, you don't need it in space. So you have to spend the first hours in space just to adjust the cabin in order to live there for a couple of weeks. And this takes time and effort, and as I said, it's the time when you don't feel exactly like well like you were on the ground. So even though I was not really sick, there is a transition phase when you are not in your best condition, and you have to do all this work at the same time. And then when you have done with that, you are in a new space. I mean, everything is changed. You can move up and down. You can work one on top of the other. Things like that. I mean, the first time was amazing. The second time was normal. I mean, I knew already what was going on. No, there are a few little differences, but to tell the truth, you cannot see it. Actually, I knew of the difference mostly after the Columbia accident, because at the time I didn't pay attention too much to the difference. But then when the accident happened and there was the investigation, then I read the reports and I noticed that there were differences. The biggest difference is that the Columbia was the first to be built. Actually, yes, it was the first to fly, basically. The first flight was Columbia, and it was also the earliest, because it was done in the 70s with no standard technology. The last shuttle, the Endeavour, I think he made his first flight in '95, if I am not wrong. And of course they use some carbon materials that made the weight, reduce the weight overall. And so that's from the performance point of view. Columbia couldn't get as high in orbit as the other three shuttles. And that was why Columbia was not used to go to the space station. Or at least was used only a few times, because it couldn't carry as much as payload as the others. Yeah, the space. I mean, the room available inside the shuttle is really very little. I mean, you cannot imagine that because you see the picture, it seems that they have a lot of room. But you have to think of the space shuttle like it's the cockpit of an airplane on the top. And you have another habitat on the bottom. So you have basically two layers, two floors. On the upper floors you have the cockpit that is no bigger than a normal airplane. And on the bottom you have a room that is a little bigger, but where there are all the basically what you need to live in the shuttle. So you have the kitchen, you can call it kitchen, or and the bathroom. That's what it is. And you have the place where you can sleep. So it's really so small that sometimes you have to work one on top of the other. But that's what is amazing about the space. You can do it. I mean, you can work on the ceiling while the other is working on the floor. Each of the crew members knows exactly what he has to do. Normally what you want to do is collaborate with the others. The competition is before you were selected. Of course there is competition because you are competing for one seat, and sometimes there are many astronauts that are ready for that seat. And so you compete during the selection process. You are always in competition. It's a competitive business. But when you are selected and you know that you are part of that team, most of the effort is done in order to make this a real good team. And that's the reason why when you are selected, normally a crew is composed of 7 astronauts, between 6 and 7 astronauts. When the 7 astronauts are selected, they are put together in one office. So they work together. 1 year before they start to work together. And so you know better the people. You know if somebody is used to talk too much on the telephone. You know if somebody is organized as a desk organizer or not. You know the people and you know how to deal with that. So you know weaknesses of each of us and strengths, so to speak. And it's a good thing because then when you are on board, as you mentioned, the room is so little that you necessarily have to interact very, very close with the people. And sometimes, you know, the space, just your own space, your own free space is something that can get you nervous. But this is what you should avoid. And the training help you to some respect, but the knowledge of the people help you a lot. Since the shuttle mission were so compacted in time, and you only have 15 days more or less, everything is planned. Everything is very strictly. I would say that you have a flight plan. Well, every half an hour you have something to do. It may be just prepare a lunch, but you have time allotted for each of this activity with the granularity of half an hour, more or less. So it's really very packed, and you don't have much free time. Basically, you work for more or less 12 hours a day, then you have 8 hours of sleep, and what is left? 4 hours you have time to prepare the meals, for prepare your bed. It's a sleeping bag that you have to fix somewhere in the cabin, and in the morning you have to roll the sleeping bag back and put it away because there is no room for other if you don't. So this kind of thing. Normally the day start with a call from the ground where they basically give you the changes with respect to the flight plan, because it's always changing. I mean, you have a flight plan that you start with, and at the end of the mission it's been not completely changed, but it's been changed significantly because every day there is new things to do or something to add or to subtract, or there might be an off-nominal situation you have to cope with, and that's happened all the time. There are small things, but you have to to deal with that. I mean, you cannot just say, well, we take care of that another time. So this is basically the activity. So normally there is a main activity planned for the day. It may be an experiment or maybe a change of the orbit. I can make an example for the first mission. No? We had this Tether satellite. That was the main goal. So we have a few days that were dedicated to this activity. So we had the time where you have to move the boom where the satellite was sitting, and then from there you start the deployment of the and things like that. And plus you have normal activities that are concerned to the spacecraft. I mean, you keep the spacecraft in good order, so you have to change the filters, because when you use air, I mean oxygen, then you produce CO2, and you have to remove the CO2 with this cartridge that are special filter, and you have to change the filter every 6 hours or things like that. So you have some kind of task that are just keep housekeeping. No, you have to keep the spacecraft in a good condition. And for major activity, you have the call from the ground. I mean, every time you have a small change, you basically talk with the ground and adjust the two teams to work together. On small tasks, you are on your own. You know, you have to start these things. You just call, I'm starting this procedure, and you go on your own. If there is a problem, then everything stops. Everything. I mean, what you are doing, you stop and you call the ground. This is something that people is not used to. I mean, you look at the science fiction movie, the astronaut starts getting an idea and doing things. In reality, when something is not what you expect it to be, you just call the ground. The first thing you do is, Houston, you don't say we have a problem. That's not NASA nomenclature, no, it's not a NASA jargon. What you do, you call Houston, you say, Houston, I am in procedure such and step such and such. I should have this, and I got that. And the answer from Houston is always the same. He said, what he said? The exact word is standby. We will be working on that. And this standby can be a few minutes, it can be an hour, because if it's a procedure that has no impact on safety, they don't work on that very, very rapidly. I mean, they just stop everything if it is a crew concern, if a safety concern. And then in that case, everything works on that. You might be surprised to know that you may stay in standby for half an hour or an hour. When you are in orbit, in reality, you are pretty safe, unless there is an emergency like a fire or something, a depressurization. In orbit, you are safe. I mean, you are going around, nothing happens. If you don't do, if you do nothing, nothing happens. And that's the very basic. So while during launch and re-entry, you have to act very, very fast. You have to be on top of what is going on, because otherwise, as I said, in a few seconds you are dead. In orbit, nothing can kill you unless there is really an emergency. So, like my commander was used to say, it doesn't matter how bad is the situation, you can make it worse. And this is really a grain of, I would say, of expertise that you have to take into consideration. So, when you are in doubt, do nothing. That's the main goal. And we are training for that. So we call the ground, we wait for them, because they have a lot of data, much more than we have. We have a small computer, well, small. It's small compared with the computer we now have on our desk. It's 256 kilobytes of memory, so something that even our cellular phone is has more memory than that. But it's still the original memory. Actually, they doubled, because originally was 128. They doubled the memory. but still it's a very limited capability of data handling. So the great part of the data, they go directly to the ground, where there are 100 people dealing with that. So when we have a problem, we better rely on the expertise that we have on the ground. And that's the reason why we are always connected. We always have radio communication, with the exception of a few minutes during the orbit, the dead zone, loss of communication. Well, all activities monitored, you're right, but you are not under pressure all the time. I mean, it's not like the Big Brother. I mean, there are cameras on board, but you are in control of that. This is the big plus. I mean, you have a switch that you can always turn and cut the ground out of the live TV if you want to. No, it is important to have this conversation most of the time, but you're right, sometimes you want just to be on your own. So the loss of signal that you got every orbit, 4 minutes, is a good break. Every 90 minutes you have 4 minutes of break, and it's used to go to the bathroom, to have a coffee and things like that, because otherwise you are always in communication, so you have to react. If the ground calls you, you have to respond, of course. So you are always in this communication situation. I think the space shuttle is definitely grounded. I mean, since July 2011, America lost its own spacecraft to carry astronauts on orbit, but they are working on the next generation of spacecraft. And the news is that they are not going to build a new space shuttle. I mean, they are not going to build a winged spacecraft, because we realized, unfortunately, with two big accidents, the space shuttle is probably the most wonderful spacecraft ever realized. But on the other hand, there are points of criticality, and the most important one was realized during re-entry, because a winged airplane need to be stabilized all the time. If you lose that control capability, of course you lose the spacecraft. While the Russian Soyuz is a ballistic system, it's more like a sphere, so it can re-entry even if you don't have a control. It just put itself in a good situation, and you just have to open the parachute at the right time. But the trajectory is pretty much a passive ballistic re-entry. While if you have a wing, you have to control actively all the way down. And so the idea is that the next spacecraft will be a capsule. So we're back to the original design, but of course a capsule of the 21st century. So it will have control capability, it will have the heat shield that could be reused several times. So the same capsule could fly maybe 20 times in space. It would be a controlled parachute, I mean some kind of parasail, so it can land in a controlled manner, hopefully in the same launch base where it was launched. So there are many things, and the idea is that this will be developed by NASA for exploration outside the Earth orbit. Basically, NASA is working on Orion. Orion is the goal. Orion is a capsule that will carry astronauts to the space station. So it's capable to carry 6 astronauts to the space station, but it can carry 4 astronauts to outer space. And the idea is it can fly to the moon easily. It can reach the asteroids. Actually, not the asteroids that are beyond the Mars orbit, but the asteroids that can get closer to Earth. You know, every now and then there are these headlines on the newspaper, asteroid is coming against us, is going to hit the Earth in 10 years from now, things like that. Normally when they say that is because the course of the asteroid is within a box of error, and in this box the Earth is considered. But pretty much when they get more and more data, this box gets much smaller, and the Earth goes out, and this asteroid goes 1 million kilometers. They pass 1 million kilometers from the Earth. That is a small distance on a universal scale, I mean on the scale of the universe, but it is a significant distance on our normal scale. I mean, but 1 million kilometers is really close, so you can get there, and you can reach the asteroids and do some digging, some analysis of the content of these asteroids. And the idea is that you can get minerals from there. The idea is there is even private companies that has been created recently in the last few years that have a goal to reach the asteroid, to mine the asteroid, to get minerals out of that and to bring it back to Earth. I don't know if that is going to happen, but I mean they put money on that, so I think they are pretty much confident that they can do it. One other approach is you send a probe to an asteroid and you bring it back on a moon orbit just to be safe, not around the Earth but around the moon, and then you go there and do the same activity. I mean, human astronaut can go there and do study and drilling and whatever it takes. This is the second step. The third step is to go to Mars, but this is really a long-term project. I mean, every now and then NASA starts saying we are going to Mars in 20 years, but that threshold has been moving, and we are always 20 years away from landing on Mars. I think this time we are getting closer though, because I see for the first time they are doing a real plan. I mean, I remember when I was there in NASA in the middle of the 90s, 95 or 96, they were studying how to get to Mars, but they were just studies. Now they are building hardware, so that means that we are really maybe 15 or 20 years away from the first mission to the moon. But the big news is that for the first time the private business, the private company they start to make plans for space exploration. They are building a spacecraft to reach Earth orbit, and also to perform outside the Earth orbit, to go beyond the Earth orbit. And this is making shape just as we talk, because it's happening. I mean, Virgin Galactic is already testing a commercial spacecraft. It's not exactly going into orbit. It cannot reach orbit because they don't have enough power to do that, but they can bring people up to 100 kilometers and then back, so it would be a suborbital flight, but long enough to stay up for a few minutes and see Earth and kind of feel the sensation of being weightlessness. It will be for very rich people at the beginning, because the ticket, as far as I know, is around $200,000 per flight. But it still is in any case less than what they paid, the few tourists that paid to go to the space station. They paid 20 million, so it's already 100 times less. And it may become even less in a few years from now. So I think that's the start. And SpaceX is next in line. They are building this capsule that is more or less the size of Orion, but is targeted to the ISS, so they will bring people up and down from Earth to low orbit and back. And the idea is that NASA will lease this vehicle for its astronauts. So basically, NASA won't own its own spacecraft, but it will use the spacecraft that's provided by SpaceX on one side, by Boeing, that is building the CX Crew CS-100, I think it is called, that is more or less the same spacecraft, also to go to the station and back. So I think the situation is evolving, and on one side you have a national space agency. They will be in charge of exploration, I mean going beyond Earth orbit in a new, relatively new territory. Earth orbit is well known, we know, I mean we have been there for 50 years now, and so now it's time for the private sector to take over. And so the low Earth orbit will be left to them. So the new enterprise will start, and will be probably the era of in which space is coming closer and closer to normal people. I mean, normal people could fly in space in 10 years from now. The balance I just mentioned is a good one. I mean, on one side, you have big investment in a situation where you have little chance of success, and this can be done only by public sector. I mean, for public investment, you need to have national space agency to invest on that, because the private sector cannot afford that kind of risk. I mean, they don't put money on high risk projects. On the other hand, you have a mature technology on low Earth orbit, and that makes sense to be developed by private sector, because they have the new idea, they have a short term of investment. They have they are more active in terms of respond to real problem than a national agency that has to plan years and years in advance. The small company can react to changes in the market or in the request from the activity. So I think this balance is important. I believe that space will really become a place where people can go if we can develop a commercial vehicle. Meaning, with this I mean a vehicle that doesn't require really a long training. I mean, if you have to train for a year in order to get on board, it's too much. It's not just so much the cost of the ticket, but the time you have to spend in order to get there. If you can just board, I wouldn't say like an airplane, but more or less, I mean, after a training section of a couple of weeks, that would be fine. So I think you have to have reliable vehicle, I mean, things that are easy to operate and easy to use and less dangerous in terms of risk assessment than the space vehicle that we have now. And that, of course, can be developed by the private sector. The only point that I would like to make is that in this respect we need some kind of national or even better international agency that take care of safety, because that's the only question. I mean, in order to get the first, you might cut corners and try the easy way to get there. In space you cannot do that. I mean, you have to to stay really on top of safety, because safety can beat you. I mean, if you just NASA had done this a couple of times and they paid a big price for that. So you cannot just say, well, we have done like this so many times that we can do it again and again. It's not like that. I mean, you have always to keep the safety first. And of course, this can be done on the national agency because it's their main goal. They have to respond to political the investors that are, in this case, public money. But you have to be careful that this happens also in the private sector. It's more or less like the airplane. I mean, you can fly an airplane, but it has to be certified. It has to be complying with all the rules and regulations in order to fly safely. I think we have to follow the same route, and so we have to create a international board that actually can certify your spacecraft is safe and this is not safe. Your certification process is okay, this one is not. So this kind of thing. I believe so. I mean, I think we just started the first steps in that direction. Once we have reached orbit, and we have done so for almost 50 years, the next step is to move to another celestial body, to another planet, or maybe another satellite, because if you think about planets, there are not so many that you can land on. I mean, Mars is probably the only one. But beyond Mars, I mean, assuming we are getting there, I mean, sooner or later we are getting there. And probably we are able to bring there a small colony, to bring a small society, human beings that live there for a period of time, maybe forever, but at the beginning at least for a period of time. This is, in my opinion, is pretty much is going to happen. I don't know if you heard about this idea that a Dutch company had, Mars One is called, to send the people to Mars one way. I mean, no return is foreseen for the time being. So I don't know if it's going to happen, probably not. But in case that is the way to build a colony on Mars. So, given for almost a sure thing that we are going to Mars, then the next step is what is next? I mean, what is the next target of human exploration? I would say that probably would be the moons of Saturn and Jupiter. Europa on one side and maybe Encelado on Saturn, because they are icy world. There is it's so cold at that point that there is just an icy surfaces. But behind that ice, it might be water, liquid water, and so it might be life there. So it would be really interesting to be able to get there, to land there, and to go all the way down 2 or 3 kilometers of ice to see what is behind that, because that's probably the best chance to find a different life form, something that has been evolving in a completely different environment from the Earth. And that is pretty much it. I mean, I don't think we have now any technology available that could make us to go beyond that point. I mean, even to get to Saturn or to Jupiter right now is out of the question, but it can be done. No? The next step after that is interstellar travels, and I believe that it takes a while to get done. I mean, science fiction, of course, has brought a lot of spaceships that can go at almost at the speed of light or even more, but in reality we don't know how to do it. So it's really interesting what is going on in the next 50 or 100 years. They might discover something completely new, some that allow us to overcome the speed of light. But even if we are able to get to the speed of light, the next star system is still very far away, and it will take us for a long trip. The other possibility is that we accept the fact that it's a one-way trip, and we just go for maybe 1,000 years, like we did, by the way, in the past. I mean, we are not now used to go to one place on the earth and come back in a matter of days or maybe weeks. But 10,000 years ago, human beings, they left for there. They decided to move with the family and a group of people and go and explore new lands. And that's how we moved from Africa. I think now we are pretty much convinced that everything started there and start colonizing all different area of Earth. It took thousands of years to do that. So why don't we can do that in space? Of course, we have to build a huge spacecraft, something like a space ark, where 100,000, maybe 10,000, tens of thousands of people could live for hundreds and hundreds of years. But it's not completely out of the question. I mean, there are two possibilities. Either we are able to go faster than light, and Einstein told us that we cannot do that unless we are very clever with wormholes or things like that. But that is science fiction for the time being. Or we go slowly, the usual way, and we take thousands of years to reach the next star. Well, it is interesting because the final few seconds of the flight, you are at the top of the speed, basically, but the maximum acceleration of the space shuttle. And the maximum acceleration of the space shuttle is controlled. I mean, you cannot go any faster than 3 Gs. So you have an acceleration of 3 Gs. That means the engine is kind of regulated to keep that constant for the last 3 or 4 minutes. So for the last 3 or 4 minutes, you are kind of squeezed by this acceleration. 3G, it seems not so much, because on F1, Formula 1 race cars, they can get even 5 Gs. But that is for a short while, I mean, just a few seconds. While we are talking about minutes here. So it's not so much the intensity, it's the time. You can basically sustain this acceleration. So you are sitting on your back, point up with this acceleration on your chest, and you have difficulty to breathe because the suit itself is already 30 kilos. Multiplied by 3 is almost 100 kilos that are pressing on you. So you have a hard time to breathe, and all of a sudden the engine quit. No? Everything is quiet, and the effect on you is that since there is no acceleration, you are moved forward, like when the car brakes, you go forward, and then you expect to come back and to sit. But then you are in weightlessness, so you kind of you are kind of floating between the seat belts and the seats, but you are not sitting, and that's the first experience of weightlessness. I was told the first time not to move too much the head around, because at that time your body is undergoing significant changes. So you don't want to upset you too much. So I stay I was sitting, but I stay floating on my seat, and I start moving around. And I felt like a dizzy because I wasn't be able to understand exactly what is going on. What is going on is that your body, your blood and your body fluids goes up, and you feel your head filled with fluid. It's like when you have headaches, you have a cold, I mean you feel that the nose is filled of fluid, things like that. So you don't feel very well at the beginning, the first hour or so. But then you get used to that, and then you enjoy really moving free, completely free. You can float, you can touch the ceiling, you can stay up on the ceiling. And this is really a new dimension. I mean, you feel free for the first time. And when you are on Earth, you don't realize that we are using only the flat surfaces. If you have to move vertical, you have to use a ladder. No? You cannot go up, and you cannot stay up. But in space, the third dimension is exactly like the other two, and you can move vertical like you can move on the horizontal. And this is really something. At the beginning, as I said, you cannot control very well how you move, because when you do some action, like you take a glass, no? You automatically calculate how it weighs and put exactly that much force. If you do that in space, you miss it because you move too much. At the beginning, it's confusing somehow. It's upsetting because you always do too much, but then you get clever and you move really with a small amount of force, and just one little movement allow you to move all the way from one side to the other. And this is particularly interesting on the space station, because on the shuttle you cannot move too much because there are walls very close to you. But on the space station you can move at the very center of the modules. You can move all the way along the main axis of the station. So you can go, well, maybe 80 meters or so, flying all from one tip to the other. And that's very interesting. I think that is something that stays with you forever. It's a great emotion when you see the Earth from space, when you realize for the first time how isolated is the Earth. I mean, everybody knows that, but one thing is knowing, and one thing is actually to witness what it means. It's all this is in your mind and in your heart, so to speak. And of course it's an emotion that you would like to have again. But it takes so long to be ready for a flight that at a certain point of your life you have to take a decision. I am going for the next mission maybe in 5 years from now, or I decide to do something else. And when you have done this, there is no way back, unfortunately. And that's why I think it is interesting that the next generation of spacecraft could be available even if you don't have all the training that you need now. So maybe at the end of my life I can have this experience again by paying the ticket this time. I would say that probably the space would be really would be reaching its maturity when you don't need to train as an astronaut in order to fly to space. Meaning professional astronaut probably is going to disappear, like it was for the aviation 100 years ago. There will be professional pilots who actually will pilot the spacecraft up and down, but people who actually use that to go to space, they won't have to be professional astronauts. They will be engineers or geologists or physicists or medical doctor. They just need to go to space for some reason. And this is going to happen, and I think that will sign really the transition to make space a normal place to live and to work. And this is going to happen in probably the next generation or two. I think the advice I can give to young generation is to keep focus on the goal, because this is what it takes to become an astronaut, but in general to have a success in professional career. The new skills that we need in space, but not only in space, require training, require a lot of preparation, require lifelong learning. It's not just a matter of going to school or to university. You have to keep up with the changes that are always moving faster and faster. So I think that's the only thing. Keep your mind focused on one side, but also open to new things. And it takes effort, of course, but at the end is the best way to be, I would say, part of the process. I mean, you will contribute to the changing, and this is a great idea. You are not, I would say, you won't be dragged by the flow, but you will part of this flow, and I think this is a great achievement.